Welcome everyone, my name is Saurabh and I'm very excited to be here on Edureka Live with you guys. So today we'll be discussing about all the basics of Python and I will also be giving you enough reasons to learn Python. But before we move forward, I want to tell you that if you have any questions in your mind during the session, please write it down in the chat box. Me and my team will reply back to you ASAP. So let's begin guys. We'll start by understanding what exactly is Python. So Python is an open source object oriented programming language with some procedural concepts as well. Now it comes with really cool features guys. First of all, it is an open source general purpose language. It supports automatic memory management and various data types as well. And it supports object oriented programming, and apart from that it's pretty portable. It runs on all major operating systems. Alright, so this is just a small introduction to Python. Let us see what are the various applications that Python comes with. Here I've listed down only 4 applications, but there are many more guys. I've listed down web scraping, you can perform testing, you can perform web development, data analysis, you can even perform automation. There are a lot of things that you can do with Python. You can even create deep learning models, machine learning models using Python. So yeah, I mean, there are like wide variety of applications that Python comes with. So let's focus on the job trend as well. So here I've compared .NET and PHP with Python in terms of demand of respective related jobs. And this data I've taken from Indeed.com. So you can see that Python is a clear winner here as well. Now let us see who all are using Python. So it is basically a list of few giants that are using Python. So YouTube, Google, Dropbox, Raspberry Pi, Netflix, National Security Agency, NASA, BitTorrent. So I've listed down only few companies that are using Python. Right, even the popular YouTube video sharing system is largely written in Python. Now Google also makes extensive use of Python in its web search system. Similarly, Dropbox, Raspberry Pi, all these companies are using Python, and yeah, it's a great language, and it can be your first programming language as well because of the ease of writing Python codes, because you don't have to worry about those complex syntaxes, right? It's very easy. The syntax is very simple, and yeah, it's a great language to start with. So we'll begin guys. We'll first see what are variables. So variables are nothing but reserved memory locations to store values. This means that when you create a variable, you reserve some space in memory, right? So you can even see in the diagram as well. So here I have 3 variables A, B and C with values 16, 20 and Edureka respectively. And all these variables, the value is stored in the respective memory locations. So I'll just quickly open my PyCharm and I'll show you there how you can declare variables. So guys, this is my PyCharm, and let me tell you how you can declare variables. So A is equals to 10. So A is a variable in which I've stored value 10, right? And when I talk about comments, so in Python, how you throw in a comment is just use this hash symbol and then write whatever you want, and that statement won't be executed. Similarly, if I have say a multi-line comments, and then I can use triple quotes, right? And yeah, write whatever you want. So I'll just write here multi-line comment, right? So it's very easy. You don't have to worry about any complex syntax. I'm again and again repeating that it's a great language to start with. And yeah, this is how you declare a variable. And one more thing guys, in Python, when you are defining a set of characters which we call strings, you need to enclose it within single quotes or you need to enclose it within double quotes. And let me tell you guys, Python cannot differentiate between single quotes and double quotes. Right, so if I have to say declare a variable B and I want a set of characters to be there inside B. So example, I want Edureka to be there. So I'll just write in here Edureka in single quotes or double quotes. It doesn't really matter. Now I can just go ahead and print both these variables just to show you how the output looks like. And that's pretty basic, 10 and Edureka, right? So let me open my slides once more. And now we'll see what is next. So now we are going to discuss about various data types in Python. So Python supports various data types. These data types actually defines the operations performed possible on the variables and the storage method. Right, so you can see in the diagram as well that the types of data types available in Python. So we have numeric, list, tuple, string, set and dictionary. All right, so let's discuss each of these in detail. So for that, I'll quickly open my PyCharm and we'll start with numeric data type. All right, so let's begin, guys. So numeric data type, just as expected, numeric data types store numeric values. And they are immutable data types. So when I say immutable, this means that you cannot change its value. And Python supports namely three different numeric data types. Integer, so what are integers? It holds all the integer values, that is all the positive and negative whole numbers. Now it even supports float and complex types. When I talk about float type, it holds the real numbers and are represented by decimal, and you can even use scientific notations at times. Complex types, so these are written in the form of a plus bj, where a and b are nothing but the float values and j represents the square root of -1. Right, so let me just quickly show you integer float types in Python. So a is equal to 10 is an integer value, b is equal to say 10.01, this is again a float value, and c is equals to 10 plus 6j. So this is a complex value, right? So yeah, I mean, you can even perform, you can convert a float type into an integer type into a float type as well. But you cannot perform the similar operation with the complex data type because the interpreter gets confused as to which value it has to convert, whether the real part or the imaginary part. Right, so I'll just quickly show you how you can convert an integer value to a float value. I'll make use of this print statement, and I'll call in this float function, and the value that I want to convert, a. So a is nothing but an integer. It has a value 10. I'm going to convert it into a float type. Let us see if that happens or not. Yep, I have converted it to a float type. Similarly, I can convert a b, which is a float type, which contains a float value, into an integer value as well. All I have to do is put b here, call in this int function, go ahead, execute this, and yep, you can see instead of 10.01, we have got 10 here. So this is all about numeric data types, guys. Let's move forward and we'll focus on the next data type that is called list. All right, so you can consider lists as arrays in C, but in list you can store elements of different types. But in array, all the elements should be of the same type. That is one major difference here. And what you need to do in order to declare a list, just put it within the square braces and separate the objects with comma. That's all you have to do. So here I've created a list. These are the names of few characters in Friends: Joey, Chandler, and Ross. So all of you who watch Friends, yeah, so you can relate to these names. Fine. So this is how you declare a list. So I've put all the objects inside the square braces. Let me just quickly go ahead and print this list for you. So yep, Joey, Chandler, Ross, right? So what I'm going to show you now is few operations that you can perform with lists, right? So the first operation that I'll tell you is slicing. Now before slicing, I need to tell you how indexing happens in Python, right? So for that, what I'll do, I'll just throw in a multi-line comment and I'll tell you how indexing happens in Python. So when I say Joey, so this is present at the 0th index of my list. When I say Chandler, it is present at the 1st index. And when I say Ross, it is present at the 2nd index. Right? So this is how indexing happens. It always starts from 0. And when you go in the reverse direction, it will start from -1. This is how indexing happens, guys. Now, when I say slicing, is to basically slice my list. For example, if I only want, say, Joey and Chandler, I don't want Ross. Right? So what I can do, I'll just type in here print statement, the name of my list, and inside the square braces, I'll tell the range. So from 0th index, I want till 2nd index, but it won't include the 2nd index value, that is Ross. So 0th index value, 1st index value, but it won't include the 2nd index value, right? So let us see if we get Joey and Chandler here or not. So yep, you can see that we have only Joey and Chandler. We don't have the entire list. Right, so let me just remove this comment, and yeah. Now, one important thing about list is that they are mutable. When I say mutable, you can update a list. You can make changes to that list once you have defined it. Right, so let me show you how you can do that. Say if I want friends, at the 0th index, I don't want Joey, right? I want something else. I want, say, Monica. right? So yeah, I'll just call in the, I'll just again print this friend list, and we'll see instead of Joey, Monica has appeared there, right? Now no more Joey there, right? So yeah, let me remove this. Now I'm going to tell you about the append operation. So when I say append, basically what happens, whatever value that I'm going to append in my list will be added at the last index, right? So yeah, let me just show you what I'm talking about. So I'll just type here friends dot append, and the value, say if I want again Monica at the end of my list, I can do that as well. Just print friends list again, go ahead, execute it, and yep, you can see that Monica, I have appended this value. That means Monica comes to the last index of my list, right? Similarly, what I can do is I can also make use of this extend function. So what happens with the extend function, instead of a single object, I can append an entire sequence. So I can append one more list here. So if I just write here, say Janice, and I write here, say Monica, and so yeah, you'll notice that this particular list will be present at the end, at the last index of this list, right? So let us see if that happens or not. And yep, you can see Janice and Monica, it is present at the end of my list, right? So yeah, this is how you update the elements of a list. And I have a separate tutorial, the name of that is Python programming, in which I've discussed all the operations of list in detail, so you can just go through that as well. Now I'll tell you how to find out the length of a list. It's very easy. Call in the length function. That's all you have to do. len, and just type in friends, go ahead, execute it, and it will show me how many elements are there in my list, which is 3. All right. Now let's talk about concatenation. So what I mean by concatenation is basically adding two sequences, right? In terms of, here, this is what concatenation means. Right, so I'm going to create one more list. I'm going to concatenate that with my friends list. So I'm going to create a subject list here. So let my subjects be physics, chemistry, or let it be physics and chemistry only. Fine. So I'm going to make use of the plus operator. Let me show you what I'm talking about. So I'll just type in here friends plus subjects. That's all I have to do. And yeah, you can see, yeah, the new list here, right? We have concatenated two lists. All right, so this is about concatenation, guys, and yeah. Now let me explain you what is repetition. So repetition basically means repeating a list multiple times. So if I want my friends list to be repeated multiple times, all I have to do is make use of this multiply operator and the number of times I want to repeat it. So if I want to repeat it twice, I'll just put in 2 here and go ahead, execute it, and yep, you can see that I have repeated my list twice. Similarly, I can type in whatever number I want. I can type in here 3 and make my list longer. Yeah, so yep, this is how you perform few operations with lists, although there are some more other operations as well. So you can just go through my Python programming video, and yeah, over there I've explained all of these things in detail. And one more last thing, guys, one last thing about lists that I want to tell you is how to reverse a list. So as I've told you that indexing in the reverse direction starts from -1. So if I have to reverse a list, all I have to do is name of my list, colon, colon, -1. And when I do that, you can see that I have reversed my list. So instead of, Joey, Chandler, and Ross, now I have Ross, Chandler, and Joey. All right, so this is all about lists, guys. So next up, we are going to focus on the next data type, that is tuples. So let's go ahead with that. So a tuple is a sequence of immutable Python objects. And I've told you earlier as well, immutable means that you cannot change its value, right? And tuples are basically sequences just like lists. The difference is in tuples, we enclose the objects within the parentheses, but in list, we enclose it within the square brackets. And apart from that, tuples are immutable, whereas lists are mutable. All right, so yeah, I mean, you must be thinking, oh, when will I use tuple, or when should I use list? So imagine a scenario when you have constant set of values and all you are ever going to do is iterate through it. So at that time, you will use tuples because tuples are faster than list, right? So because you have only constant set of values and you don't need to update it, you are only going to iterate through it, right? So that's when you can use tuples. So enough of that. I'm just going to quickly show you a few operations with tuples. Although whatever operations that I've shown you with list, you can perform that with tuple apart from updating a tuple, right? So let me just quickly print this tuple Chelsea. All right, it has 3 elements in it: Hazard, Lampard, and Terry. well, they are my personal favorites. So yeah, you can see that we have successfully printed the tuple. Now, what I'm going to show you is few operations that you can perform with tuple. Like I can find out the length of my tuple. Right. So yeah, let's go ahead and see the length of my tuple. So it has three elements. Right. So it's pretty easy. Now, what I can show you is I can perform slicing like I've done for lists. So from 0th index till I want second index, I only want hazard alarm power. I don't want Terry. And remember, guys, in Python, always indexing starts from 0. Whether it is a list, whether it is a tuple, whether it is a set, whatever it is, always indexing will start from 0. Right, so let's go ahead and execute this. So yep, only I have hazard and Lampard. I don't have Terry present in my uh, uh, tuple, right? So similarly, I can reverse this tuple as well. All I have to do colon colon -1, and yep, I have reversed my tuple as well. Now I'm going to prove it to you that you cannot upgrade a tuple, right? So let's use Chelsea. Say if I want instead of hazard, I want something else. Say if I want here Mikhail, right? So now let us try printing this tuple and we'll see what happens. So yep, you can see this particular error. Tuple object does not support item assignment. You cannot make any change to a tuple. All right, even if I call in the append function, there won't be any change in my tuple. So append, what value you want to append, say again Mikhail. Go ahead, print this tuple and we'll see what happens. So yep, tuple object has no attribute append. So basically you cannot append, you cannot update a tuple once you have declared it, right? So yeah, and all the operations apart from that are pretty much similar to lists. So you can just try it yourself. It's very, very easy. And yeah, so this is all about tuples, guys. Next up, we are going to discuss about strings. All right, so what is a string? String is basically, a set of characters, right? And how we create them? We create them simply by enclosing characters in quotes. Single quotes, double quotes, doesn't really matter here, guys. It's Python. You don't have to worry about those complex syntaxes, as I've told you earlier as well. Simplicity is always better than complexity. And yeah. So yeah, it's my personal favorite language, and you don't actually have to worry about any syntax here. So all you have to do is enclose your set of characters in quotes, single quotes, double quotes, doesn't really matter. So yeah, over here I've already declared a string, and it is welcome to Edureka. Let us try printing the string, and yep, welcome to Edureka. Now there are a lot of operations that you can perform with strings as well, but before that, let me tell you guys, again in strings as well, you have indexing, again in strings also indexing starts from 0, right? Nowhere indexing is starting from 1 in Python. So yeah, I mean, let's see a few operations that you can perform with strings. So I can find out the length of my string. Just need to type it lens, and yeah, just go ahead, execute it. So we have 19 characters in my string. Right. So now what I'm going to show you is I'm going to show you how you can find out the index value of a particular character. Say if I want to find out the index value of L, right? So what I can do is just type in the name of my string, which is S dot index, call in this index function, and the character. So if I want to find out for L, I'll put L within quotes or single quotes, double quotes, doesn't really matter. Let's go ahead and execute this. So it is present at the second index. Count it yourself. 0, 1 and L is 2, right? So this is the second index. Similarly, if you want to know how many times a character is repeated in a string, so instead of this index, you can just type in here count. And yeah, if I want to find out how many times E has been repeated in my string, I'll just put E there. And yeah, 4 times you can see the string E is present in my string. Right, now again, I'll tell you slicing. So it's again very, very easy, guys, like we have done for lists and tuples. In strings also it happens in the same way. Say if I only want WEL, so I'll just type in here 0 colon 2. No, actually 0 colon 3 because it's present at the second index, and yeah. So I have only WEL here, right? So it's that easy. And again, I can reverse this particular string as well because indexing starts from -1 in the reverse order. Just go ahead, execute it, and I have successfully, reversed a list. Similarly, I can convert my list to all the letters in my list to uppercase as well. All I have to do is call in this upper function, and yeah, it is done. Go ahead and execute this. Similarly, there is one lower function as well, so it will convert the all the characters in my string to lowercase values, right? Now let me tell you how you can perform concatenation. So I'll declare one more list. Let it be Python is great, right? So all I have to do is again use a plus operator, and it's done, guys. It's that easy. Yeah, Python is great. It is actually great, right? So yeah, this is about concatenation. Again, I can repeat one string multiple times as well, call in this multiplication operator, and the number of times you want to repeat it. So if I want to repeat it twice, just go ahead, type in there 2, and yep, you can see that you have repeated your string twice. So this is about strings. Let's move forward, and we are going to focus on next up, excuse me, guys. So now we are going to focus on sets, right? So again, sets are also very, very easy. So let me just open it for you. Yeah, fine. So what is set? A set is nothing but an unordered collection of items, and every element has to be unique in a set, right? So when I say unique, let me tell you what I'm talking about. Don't worry about the rest of the code that is written. Let me just throw in a multi-line comment, and yeah, so that you guys are not confused about anything. And yeah, I'm going to create a set, s is equal to, and when I create a set, I need to enclose my elements within curly braces and separate them with comma, right? So if I have say 1 comma 2 comma 3, and this is my set, guys, and I just need to type in here print s, and you can see that my set will appear in yeah, so here it is. Now I'll show you one thing. If I go ahead and repeat 3 twice, we'll see what happens when I try to print this. So yep, you can see that 3 has appeared only once, because set is, again, I'm repeating, it is an unordered collection of unique items. Every element in a set has to be unique, right? And for declaring a set, you can even call a built-in set function. All right, so what I mean by that is, suppose if I make this as a list, right? So this is now a list because I've enclosed within a square braces. Now, if I want to convert this to a set, I need to call this set function, and within that set function, I'll just type in the name of the list. Just go ahead, execute this, and yep, you can see that I've converted this list into a set, right? So it's that easy. Now let me remove this, and we'll see pretty cool operations that you can perform with set. The first operation that we are going to discuss is known as union. All right, so when I say union, it means, for example, if I have A and B, both are sets, so all the elements from both the sets, that is basically what union is, right? So if I have 1, 2, 3, 4, 3, and in set A, and I have 3, 4, 5, 6 in set B, when I perform the union operation, so I'll get output something like 1, 2, 3, 4, 5, 6. But there won't be any values which will be repeated, because again, set is an unordered collection of unique items, guys, right? And this is the symbol for union. I have two sets, A and B, and I'm going to perform the union operation. Let us see how our output looks like. So it's 1, 2, 3, 4, 5, 6. All right, so it's as I've told you, what is union? It is basically all the elements. And yeah, so you can notice that apart from these, apart from this set, there's nothing else in A and B. I mean, there's nothing apart from this, right? So yeah, that's what I wanted to tell you guys. Now, next up, I'm going to tell you about intersection, right? So let me just remove this comment here from here, and I'll put it here. All right. So when I say intersection of A and B, it is nothing but a set of elements that are common in both the sets. So see, A has 1, 2, 3, 4. B has 3, 4, 5, 6. So what are the common elements here? 3 and 4, obviously, right? So I'm just going to use this operator. This is basically for intersection. If I print this, I'll get only 3 and 4. Yeah. So this is what basically intersection is. Now we are going to discuss the next operation that is called difference. Let me remove this first. Yeah. So when I say difference, or when I say A minus B, that means it is a set of elements that are only in A but not in B. Right, so if you notice, if I write A minus B in the current set that I have, A and B, so what are the elements that are present only in A but not in B? Obviously, it is what? 1, 2, and 3, right? Only 1, 2, and 3 are present in A but not in B. As you can see, 4 and 5 is also present in B. So when I say A minus B, that means the elements that are present in A but not in B. And when I write B minus A, that means elements that are present in B but not in A. Currently, I'm doing A minus B, so 1, 2, and 3 should appear in my output, and yep, it does. So this is about difference, guys. Let me remove this now, and I'm going to tell you about symmetric difference. Now, when I say symmetric difference of A and B, it is nothing but a set of elements in both A and B, except those that are common. All right. So all the elements in A and B, or you can say all the uncommon elements in A and B. That is what basically symmetric difference is. So if you notice 1, 2, 3 and 6, 7, 8 are the uncommon elements, because 4 and 5 is present in both the set A and B. Right, so let's go ahead and perform symmetric difference here, and 1, 2, 3, 6, 7, 8, because 4 and 5 are common in both the sets, right? So now we are going to move forward with the last data type, that is dictionary. So dictionary, what is dictionary? Basically, it is nothing but a sequence of key value pairs. All right, so let me explain you this with an example. So I'm guessing you guys know about Aadhaar card, right? So for those of you who don't know what it is, so it is nothing but a unique ID which has been given to all Indian citizens. So for every Aadhaar number, there is a name and few other details attached. Now, you can consider the Aadhaar number as a key and the person's detail as a value attached to that key. And dictionaries are nothing but the key value pairs enclosed within curly braces. And the key value pairs are separated with comma. And when I say keys and values, so they are separated by colon. So over here you can notice I have created a dictionary. How about I create a new dictionary? It doesn't really make any sense. It doesn't make any sense. So right, let the name of my dictionary be employee, right? And I have my first key as name, and the value that is attached to it is, say, Saurabh, right? Now the next key value pair is going to be age. The value that is attached to it will be, say, my age, let be 42. Right, so I have here two key value pairs, and this is my dictionary, and the name of my dictionary is employee. So I'm just going to type in here employee, and let's go ahead and print our dictionary, and yep, you can see that we have our dictionary here. Now, when I want a particular value that belongs to a key, that is attached to a key, so I can just use the key. Let me tell you what I'm talking about. So if I write here print employee, and in the square braces, if I type the name of the key, right, and if I execute this, so you'll see that the name will appear here, that is Saurabh. Similarly, if I type in here, say, age, so age will appear, that is 42. Right, so this is dictionary, guys, and now enough with the data type. Now is the time to see various operators that are there in Python. So for that, I'll open my slides once more. So operators are nothing but the constructs which can manipulate the values of the operands. All right. So when I say operands, consider an expression. Say 2 plus 3 is equals to 5. So here 2 and 3 are operands, and the plus operator, the plus symbol that we use, is nothing but an operator. And Python supports various operators. There are comparison, identity, logical, arithmetic, assignment, bitwise membership. So let us discuss each of these operators one by one. I'll start with assignment operator, and for that I'll open my PyCharm. Let me just quickly open the, I'll start with arithmetic operators, guys. I'm sorry. All right. So arithmetic operators, so these operators are used to perform mathematical operations like addition, subtraction, multiplication, etc., etc., etc. Right. So yeah, let's understand this with the help of the code that is there in front of your screen. So we have three variables A, B, and C with values 21, 10, and 0 respectively. Now what I'm going to do is perform addition first. So I'll have a variable C which will be equal to the addition of A and B, A plus B. And I'm going to print this here, print C. Right. Similarly, I'm going to perform difference. I'm going to calculate the difference between A and B, multiply A and B, divide, and this is used to calculate the remainder. this is for exponent, and this is called fab division, which means that it will ignore the remainder and will only give you the quotient. But when I say here, this means a raised to the power b, right? So 2 to the power 3. And similarly, a is 10 here and b is 5. So yeah, it's pretty basic, guys. I'll just go ahead and run this. So addition, after adding the two values, I got 31, subtracting, I got 11, multiplying, I got 2100. When I divided both values, I got 2.1. What was the next operation? Yeah, when I calculate the remainder, the remainder value is 1. Then I performed 2 to the power 3, which is nothing but 8. Yeah. And yeah, and then I calculated the quotient, or you can say fab division, and that turned out to be 2. Right, so this is all about the arithmetic operators that are available in Python. Next up, we are going to discuss about the comparison operators. All right, so comparison operators, basically they compare the values on either sides of them and then decide the relationship amongst them. So whether it is greater than, equal to, less than equal to, greater than equal to, that sort of stuff, right? So yeah, I mean, let me just throw in a multi-line comment here so that you guys won't be confused. Yeah. Right. So what I'm going to do here is I'm going to make use of this comparison operators, and I'm going to write in here, say if A, this is for less than B. Right. So if this is true, I'll get the output as true. Right. But currently, if you see, A is actually greater than 10, and this is saying A is less than B. So if I go ahead and execute this, it is false, right? And the moment I make it greater than B, and if I now execute it, it turned out to be true, right? Now, I'm going to show you equal to operator. So is A is equal to B? I don't think so. Let us see if it returns a false value or not, and yup, it does. What if I make this as 21? Now let's see if it comes true. Turns out to be true. Yep, it is. So what it is doing, it is deciding the relationship among them, whether it is equal to, not equal to, less than equal to, right? If I just write in here less than equal to, and I make this say as 13, right? So currently you can see that A is actually not less than equal to B, so it will return a false value, right? And the moment I reverse this, I type in here greater than equal to, so that is absolutely correct, right? And even if I make this as 21, it'll again be true because we have an equal to operator as well, greater than equal to, right? Similarly, we have smaller than equal to as well. So this is how comparison operators work, guys. And the below code that you're seeing here is over here. I'm using the if and else statements, and after that I'm calculating whether A is greater than B or not. So I'll tell you about these conditional statements later in the session, so you don't need to worry about it currently. Just remember that in comparison operators, we have mainly equal to, not equal to, less than equal to, and greater than equal to, greater than, smaller than. Right, so I didn't show you the less than equal to operators. This is how it looks like. So currently A is actually equal to B, so this will return as a false value, and yup, it does. So at the moment I make it as 2, and now if I try to execute it, it returns me a true value because obviously A is not equal to B, that's why it is returning me a true value, right? So this is how comparison operators work, guys, and yeah, so let's see what is the next operator that we are going to see. It is nothing but assignment operator. Let me open that in PyCharm. So when I say assignment operator, it is used to assign a new value to a variable. So let me explain to you with the code that is there in front of your screen. So here we have three variables A, B, and C with values 21, 10, and 0 respectively. Now what I'm going to do is update the value of C in the code itself, right? So how I'm going to do is I have C here, which is nothing but A plus B, the arithmetic operator plus I've used, right? Addition operator. Now, then what I'm writing here, C plus equal to A. This means that C, let me just throw in a comment here. This means that C is equal to C plus A, right? So whatever the value that comes after adding C and A will be stored in C, right? Similarly, when I say C multiply equal to A, it means that C is equal to C into A, right? So this is how it works. Even same goes for division as well, and yeah, mod calculating the power value like c to the power a. Similarly, fab division as well. So we are constantly updating the value of c, right? So just let me quickly run this for you, and yep, you'll see over here. So after adding a and b, I got 31. After that, what I did, I updated the value of c. So the c value was earlier 31. When I added 21 to it, it became 52. And again, it was stored in C. Similarly, you can see the other operators as well. So after that, I performed multiplication, then division, then calculated the remainder. After that, I calculated c to the power a. Then I performed the fab division as well. So this is all about the assignment operators, guys. So next up, we are going to see bitwise operators. So let me just quickly open that .py file, right? So bitwise operators, so these operations directly manipulate the bits. So obviously in all computers, numbers are represented with bits, a series of zeros and ones. And in fact, pretty much everything in a computer is represented by bits, right? So whatever operation that you'll see in the over here will be performed bitwise. So whatever number we have will be converted to a binary value, and then bit by bit those operations will be performed. So namely, we have bitwise AND, bitwise OR, bitwise XOR, a left shift, a right shift, right? So these are all the operators that we have here, and yeah. So this is what basically it is, and let me just quickly show you that in the pie chart as well. So we have three variables a, b, and c with values 58, 13, and 0 respectively. So over here you can notice that I've converted these values into a binary format, right? So in terms of zeros and ones, and I've thrown in a comment here which gives you the binary value. Right. So the first operation that you'll see is basically the bitwise AND operator. So I am guessing that you guys know about the truth table of AND, and yeah, let me just quickly tell you about the truth table of AND gate, which means that if I have one input as 0, another input also as 0, then my output is 0. When I have one input as 0 or one input as 1, then my output is also 0. Again, if I have say one input as 1, another input as 0, then also my output is 0. But the moment I have the two high inputs, my output also becomes high. This is about your AND operators, right? So when I perform the bitwise AND operation here, you can see that I'll get 8, right? So just go ahead and do that. Let me shift it here. 0 and 0 and 1, 0. 1 and 0, 0. 0 and 1, 0 again, and then 1 and 1 is definitely 1, right? So yeah, it's pretty basic, guys, but yeah, whatever it is. So this is how you perform bitwise AND. When I talk about bitwise OR, in bitwise OR, your output is always high. Your output is always high basically, and your output will be low only when both your inputs are low. So only when you have a condition like 0, 0, then only your output will be 0, else it will always be high, right? Even if you have only one input high, then also your output will be high. But when I talk about binary XOR, when you have both high inputs, then your output will be low. Now this is basically telling you about left shift. So it will shift A 2 bits towards the left. It will shift A 2 bits towards the right. So yeah, just try doing this. You just shift left A 2 bits. So this is what you're going to end up with. Right, so just go ahead and do it yourself. So this is what you're going to end up with. Same goes for right shift as well. So just shift the bits right towards right, and this will come here, and again, so this is how it is going to look. The output will be 14. Let us see if that happens or not. And yep, it's pretty accurate, guys. 8, 63, 55, 232, and 14. So yeah, I mean, this is all about bitwise operators. Next up, we are going to discuss the logical operators. So for that, I'll go to that logical operators.py file. Yeah. Pretty basic. You just need to have understanding of AND gate, OR gate, XOR gate. So I'll just type in the truth table for AND, OR, and NOT. So yeah, so we have three logical operators: AND, OR, and NOT. So when I talk about AND gate, in it I have told you although about it, but yeah, I'm just gonna type in here 0, 0, 0, 0, 1 is 0. 1 0 is 0, 1 1 is 1 for AND gate, right? Now I'm going to write the truth table for OR gate. So as I've told you earlier as well, in OR gate, our output is always high and it will only be low when your both the inputs are low. So when 0, 0 are both my inputs, then my output will also be low. And when one input is low, another input is high, then also my output is high. Similarly, if one input is high, another input is low, my output is again high. If both of my inputs are high, then also my output is high. So this is about your uh, OR gate. And NOT is nothing but the complement. So if you have 0, it will become 1. If you have 1, it will become 0. If you have a true value, it will become a false value. If you have a false value, it will become a true value. So yeah, that's all. That's about the truth table. So I'm just going to quickly show you first of all the AND operation. So print X and Y. I need to either this is basically that AND operator. So currently you can see that both my inputs are true or both of my inputs are high. So this should return me a true value. And yup, it does. The moment I make it as false, and now if I try to execute it, it'll return me false value, right? Because yeah, I mean 0 and 1, that sort of deal is here. And yeah, let me just convert this to true again, and I'm going to use the OR operator now. Just go ahead and run this. So yeah, true. The moment I make this as false, then also it will return a true value. Yeah. And if I make both the inputs as false, then it will return me a false value, right? Now I'll show you the NOT operation, NOT of X. So X is false, it will convert this to a true value. Yup, it does. So yeah, this is about the logical operator. Next up, I'm going to discuss about the membership operator. So basically we have two membership operators, in and not in. These operators are used to test whether a value or a variable is found in a sequence, and that sequence can be list, tuple, sets, strings, dictionaries, right? So yeah, I mean we have a value a, we have variable a that has value 10, and we have a sequence that is 1, 2, 3, and 4, right? So let me just remove this. I'm just gonna write in here in. So if I use this in operator, it will return true if the value or the variable is found in the sequence, right? So yeah, it currently it should return me false because this particular value is not there in the sequence. So let us see if it returns a false value or not, and yup, it does. It returns a false value. Right, so the moment I make it as 1, now you can see that it is true because the value is there in the sequence, or the variable is there in the sequence, and yep, it returns me true. Right, so let's talk about a not in operator now. So it's just the opposite of in. Not in what happens, it will return true if the value or variable is not found in the sequence, and it will return false if it is found in the sequence. Currently, it will return false because 1 is present in the sequence. And yep, it does return false. The moment I make it as 10, so it will return me a true value because the variable is not present in my sequence, right? So yeah, this is about the membership operator. So basically it will test whether a particular value or a variable is a member of a sequence or not. Now let's talk about the identity operator. Alright, so identity operators are used to check if two values are located on the same part of the memory. Or you can say two variables that are equal. It does not imply that they are identical, right? So let me just explain you with the code itself. So we have two operators here, two types of identity operators, is and is not. So is will return true if the operands are identical, and is not will return true if the operands are not identical. All right, so yeah, I mean, let me just remove all this, and x2 is equal to say 10, and I'll make it as 10. All right, so yeah, I mean, currently you can see that both the variables are identical, right? So is should return as a true value and is not should return as a false value, and let us see if that happens or not. Yep, it happens, right? You can see in the output as well. The moment I make this unidentical, you can see that we have true and false. So this becomes true and this becomes false. So yeah, it's pretty easy, guys, and yeah, I mean, nothing, no rocket science here. Python is very easy. Again and again, I'm saying that. Now I'll open my slides and we'll see what is next. So we have covered all the operators, guys. And I have a separate tutorial again and again. I'm telling you Python programming, just go through it. I've covered all the basics there as well. So now we are going to discuss about conditional statements. So conditional statements are used to execute a statement or a group of statements when some condition is true. And there are namely three types of conditional statements in Python: if, elif, and else. So let me explain you that with the flowchart that is there in front of your screen. So control will first check the if condition. If x is less than y, and if this condition is true, then it will execute the statements present inside this if condition, right? So whatever the if code is there, that will be executed. That is statements underscore b. And if this is false, it will check, the control will check the elif condition. And if this elif condition is true, it will execute the statements underscore b, or you can say the elif code. And the moment control finds out that this is also false, it will by default execute the else statements and statements underscore c. So this is how conditional statements work, guys. I'll quickly open my PyCharm and I'll show you there as well. Where is conditional statements? Yeah, here it is. Very easy, guys. What I have done, I have two variables x and y with values 14 and 13 respectively. So my if condition says that if x is less than y, print x is less than y. Elif x is greater than y, print x is greater than y. Else, and I don't need to specify any condition here, it will take the condition, it will take it by default. So the condition here will be x is equal to y. And if else condition is true, then x and y are equal. So currently you can see that x is actually greater than y. So it should execute this elif code, that is x is greater than y, and let us see if that happens or not. And yep, it happens. Let me change the values a bit. Now it should execute the if statement because x is less than y. So yep, it does. And the moment I make it 13, we'll see that the elif condition becomes true and x and y are equal. So this is about conditional statements, guys. And yeah, I mean, it's easy, only three conditional statements. So we have if, elif, and else, right? So let's see what is there next. We are going to discuss about loops now. So let me tell you why we need loops and then we'll see what exactly loops are. So in general, what happens? Statements are executed sequentially. The first statement in a function is executed first, followed by the second, and so on. But what about a situation when you need to execute a block of code several number of times? And so what you'll do in that situation? So you'll use a loop. So basically a loop allows you to execute a statement or a group of statement multiple times. So yeah, and let me explain you with the diagram that is there in front of your screen. So the control will first check the condition, right? First the control will check the condition. If it is true, then the control will move inside the loop. And it is going to execute the statements that are present inside the loop, or you can say the conditional code. And after executing that, it will again check the condition. If again the condition is true, it will again execute the conditional code. It will keep on repeating until my condition becomes false. And the moment my condition becomes false, the control will come out of the loops. Now there can be two types of loops, guys. It can be infinite or it can be finite. So when I say infinite, that means the condition will never become false. And when I say finite, so at one point in time, the condition will become false and the control will move out of the loop. Although there is one more way to categorize loops, you can call that as pre-test and post-test. So when I say pre-test, in this type of loops, the condition is first checked and then only the control moves inside the loop. But when I talk about post-test loop, here first the statements inside the loops are executed and then the condition is checked. Although in Python, there is nothing like post-test loop. There are no post-test loops, right? So there's no do-while loop in Python. So in Python only we have pre-test loops. So let us see what are the different types of loops that are available in Python. So namely, there are while, for, and nested loops. Right. So yeah, let me just open my PyCharm for you, and we'll discuss with basic while loop. So let's start with while loop. So in while loop, first the condition is checked, and if it is true, the control will move inside the loop and execute the statements that are present inside the loop until the condition becomes false. Now the question is when we will use while loop. So we'll use this loop when we are not sure of how many times we need to execute a group of statements. Or you can say that when we are unsure about the number of iterations. So I have a pretty good example in front of your screen. It's pretty basic, although I'll increase the complexity a bit and I'll tell you another implementation of while loop as well. But this is very basic introduction to while loop. So I've declared a variable count which is equal to 0, right? And my while condition says that while count is less than 9, colon, don't forget the colon guys, this is a syntax, very, very important. While count is less than 9, print the count is count. So print the current count and then increment it by 1. Right, so it will keep on doing this until this condition becomes false. So the moment my count value becomes equal to 9 or greater than 9, it will come out of the loop and it will print goodbye. Right, so first 0 will come here, 0 will be printed, then the value of 0 will be incremented by 1, it will be saved in the count, again it will check the count condition, so 1 is obviously less than 9, again it will move inside the loop, print the count, increment it by 1, again check the condition, keep on repeating until the condition becomes false. At the moment the condition becomes false, print goodbye. Let us run this and we'll see what happens. So yeah, the count is 0, 1, 2, 3, 4, 5, 6, 7, 8, and then finally we are printing goodbye. Right? So yeah, let me just quickly show you one more while operator here, guys. One more implementation of while loop. I'm sorry. So here I'm going to play a little guessing game, and yeah, so I'm importing a random module. So this is basically used to generate a random number between 1 to 20. And my n is 20. So there will be a random number that will be generated, which is of integer type. Right. So I have to guess this number. So inside the while loop, I have written a condition when the number that I have guessed is not equal to the number that I have guessed, that the number generated by my system. Then check the if condition. If guess is greater than 0, so basically the moment you input a negative number, you're out of the game. So if guess is greater than 0, it will again check one more condition. Guess is greater than to be guessed, print number is too large, elif print number is too small. And the moment you put in, you have entered a number that is less than 0, it will print, sorry, you're giving up, break, goodbye. And the moment you have guessed it correctly, that means this condition is false. Congratulations, you have made it. So let us quickly go ahead and run this and let us see how good I am at this game. So I need to guess a number between 0 to 20. So let it be 10. It is too small. So that means it is between 0 to 10. How about 7? Number is too small. Alright, I'm sorry, I'm very sorry. Since the number is too small, so definitely it will be above 10. So how about 13? It is again too small. How about 15? It is again too small. How about 16? It is also small. How about 17? Again 18. It is also too small. 19. Yep, it was 19 for God's sake. Yeah, I'm pretty bad at this game. But yeah, this is how you do it. It's very, very easy. Ask the user to input a value. If that value is not equal to the number generated by my system, check all these conditions. It has to be greater than 0, and the moment it is greater than 0, is it greater than the number generated by the system? If it is, then print number is too large. If it is less than, then print number too small. At the moment you have input a number that is less than 0, you are out of the game, buddy. You can't play this game. And input function is basically to input a keyboard, to give an input through our keyboard, right? So yeah, I'm going to tell you about for loop as well. So yeah, this is about for loop, guys. Let me just quickly tell you about for loop. Yeah. So when I talk about for loop, it is basically, it allows us to execute a block of code multiple number of times like the while loop. But the difference is in for loop, we know the amount of iterations required, unlike the while loop. And let me tell you with example, you'll get a better idea here. So I have a fruits list here, banana, apple, and mango. I'm going to type in here for fruit. In fruits, I've given a range here that is fruits, that is basically my list. Print the current fruit. So it will print banana, apple, and mango. And the moment it is done with that, it will print goodbye. So let's see if that happens or not. And yep, it does. Current fruit, banana, apple, mango, goodbye. So guys, this was about for and while loop. There is also nested loop and a lot of other concepts that that Python comes with. But unfortunately, the time does not allow me to take this session any further. Before that, I'll just quickly tell you about the Python certification training provided by Edureka. So you can just go ahead and enroll here, www.edureka.co/python. Over here, all the concepts are covered from scratch. You don't require, there's no prerequisite for this course, and whatever is required is included in this course, right? Guys, you get 24/7 support. All the classes are live online instructor-led training here, and you have the lifetime access here. Whatever course you enroll with Edureka, you get a lifetime access of that course. So even after 6 months, if you want to repeat the course, if you want to take the batch again, you can just go ahead and do that. And batch timings are also pretty flexible. If you're not comfortable with the batch, or if you missed some amount of classes, you can go ahead and enroll in the next batch as well. So it's all is it's pretty flexible, and the best part is you get 24/7 support. So at any point in time you face any doubt, just go ahead, dial the support number or raise a ticket, and they'll solve all of your doubts. Now we also have a playlist on Python on YouTube, so you can just go through this playlist, and all things are covered here: Python class, loops, sequences, then few applications of Python that are there in Python course, Python programming language, interview questions, Python Selenium, machine learning, data analysis, regular expression, NumPy, Matplotlib. So yeah, all of these things are there, and what you need to do is you need to click on this bell icon here. All right, so yeah, there's a bell icon when you actually sign into YouTube. You will notice that there is a bell icon that will actually give you a prior notification. Like 30 minutes before the live session starts, you'll get the notification that Edureka there is a live session that will be happening in Edureka. And last thing, guys, since you have stayed in the session till the end, so we are ready to offer you some discount on any of the course that is provided by Edureka. All right, so all you have to do is open this particular link, resources.edureka.co/edureka live course offer, fill in the survey form, and you are eligible for the discount on any of the course that Edureka provides you guys. All right, so yeah, this is all for today's session. In the upcoming sessions, we are going to discuss about functions and object-oriented programming concepts, and yeah, so all those things we are going to cover in the next session. So yeah, thank you guys for attending, and thank you guys. Yeah, I hope you have enjoyed it.